Hello students. So today we will be seeing introduction to the steel structures. So as a structural engineer, one must be aware about the structure. So what is a structure? A structure is nothing but a combination of elements or members connected together to sustain the applied loads and transfer it safely to the ground. It's called as a structure. Then a field of civil engineering dealing with the analysis and design of a structure that resists the load is called as a structural engineering. Now, what does mean by structural engineer? That is an engineer who deals with the analysis and design of an structure. Then the structural design is classified into two categories as functional aspect and strength aspect. Now in our subject, that is design of steel structure, we will be designing the steel structures. Here in the diagrams, here we are having two diagrams. First one is the plan of a structure and the second one is the structural detailing. And the third one is the elevation of the structure. If you see in the next slide, we will be discussing with the types of the structures. There are four classifications of the structure depending upon the use of material, then based upon the analysis of the structure, then based upon the load transfer, and last one is based upon the design life. First one, that is based upon the use of material, structure is classified as concrete structure, steel structure, or a composite structure. Then based upon the analysis of a structure, structure is classified as an determinate or indeterminate structure. Then based upon the load transfer, the structure is classified as a load bearing or frame structure. Lastly, depending upon the design life period, structure is classified as an temporary, permanent, or important structure. Now we will study what does mean by members of a structure. Depending upon the orientation of the members and its uses, the structure is subjected to the axial force or bending action or shear force or torsional force or maybe combination of all the above. Then depending upon the types of the loading or the force, the member is classified as an tension member, compression member, or a flexural member. Then coming towards our steel structure, a steel structure is an assembly of group of elements interconnected with and interconnected and expected to sustain and transfer the load acting upon it. The elements are rolled in cross section to standard shapes in the shop and connected with riveted or bolted or welding. If you observe in the diagram, there is a simple diagram of a simple sketch of a truss, and these are the elements or the sections, cross sections, which are being utilized for the design of any steel structure. Depending upon the English alphabets, the structures are classified. The structures are named as channel section resembling the alphabet C, I section resembling the alphabet I, T section resembling an alphabet T. Here we will be studying what is the difference between or comparison between the steel structure and concrete structure. Now, what does mean by concrete structure and steel structure? Concrete structure, it is nothing but structure cast in situ with the with steel and concrete, and steel structure are directly erected with the help of a structural steel. So the first difference is the casting of the concrete structure is in situ, whereas that is it is casted at the site, and steel structure are fabricated and erected at a site. Concrete structure has a controlled cross section and shape, whereas the steel structure is rolled steel sections are utilized for construction of the steel structure. Then in concrete structure, higher weight to the strength ratio is observed, whereas in the steel structure, smaller weight to the strength ratio is observed. Coming towards the speed of the construction, the speed of the construction is less in the case of concrete structure, whereas if we compare it with the steel structure, the rate is faster. Then, if we look at the area available for the usage, in the case of concrete structure, there is obstruction of the column, whereas in the steel structure, large column free area is available. Taking the advantage of this point, large industrial sheds, godowns, industrial buildings are designed by using the steel structure. Next, the transportation is very difficult in the case of concrete structure, whereas in the case of steel structure, the transportation is easier one. If we look at the upgradation of the structure, in the concrete structure, it is very difficult to add and alter the structure, whereas in the case of a steel structure, it is very easy to upgrade and expand the structure. Then coming towards the scrap value of a structure, the concrete structure has zero scrap value, where as compared to the concrete structure, steel structure has a large scrap value. Recycling of the material. Here, the concrete structure, small part, that is the steel can be recycled, concrete cannot, the other concrete part cannot be recycled, whereas all the materials which is used in the steel structure can be recycled. Concrete then come depending upon the brittlety or ductility. The concrete structure is brittle than that of the steel structure, whereas the steel structure is ductile. Then comparing the gas tightness and water tightness, the concrete structure is less tight where as compared to the steel structure. But if you compare the steel structure, as the density is high, the tightness is possible in the case of the steel structure. Then coming towards the properties of the steel structure, IS 800 2007, page number 12, clause number 22 2.2.4.1 gives us idea regarding the properties of a steel structure. Classification is done based upon the ultimate or the yield strength of the material, that is Fu or Fy. The mechanical properties depends upon the chemical composition or the rolling method, heat treatment, etc. Chemical composition, here in the structural steel, 95 to 98% the composition is of iron, but it also constitutes different 5 elements. First one is carbon. Carbon is up to 2%. then it's a low content of carbon. If it's greater than 2%, then it is high percentage of carbon. Then manganese 1.5%. Next sulfur 0.5%. Then phosphorus 0.005%. Last one comes the silicon, that is 0.4%. Then other composite, then the weight of the unit mass of a steel, it is 7850 kg per meter cube. Next, modulus of elasticity 2 into 10 raised to 5 Newton per mm square. Next, Poisson's ratio, it is 0.3. Modulus of rigidity, it is 0.769 into 10 raised to 5 MPa. And coefficient of thermal expansion, it is 12 into 10 raised to 6 per degree Celsius. These are the properties of a structural steel. As told previously, these properties are available in our IS code on page number 12. Then we will be studying the various rolled steel sections which are utilized for the design of a steel structure. The first section is I, second section is channel section, third one is the T section, then it is the angle section, then IS flat plates, then the round bar, then the square bars, and last one is the plates. The first section, if you observe here, I section, it resembles an English capital alphabet I. The top of the figure, that is the top portion of the section, is called as the flange. The part connecting these two flange is called as a web. The width of this flange is denoted by BF, and TF resembles the thickness of the flange. Small h resembles the height of the section. TW is the thickness of the web. Root radius and is resembled by R1, and root radius at the toe is resembled by R2. Then the channel section resembling an English alphabet C. Similarly, here we are having web portion and flange portion. The web portion, the thickness of the web portion is TW, and thickness of the web TF, width of the flange BF. R1 is the root radius 1 and R2 is the root radius at the toe. Then the T section. The T section is having thickness of the flange as a BF, thickness, width of the flange as a BF, thickness of the flange as a TF. H is the height, TW is the width of the flange web. Then the angle section. The angle section is having two legs, leg A and leg B. Depending upon this leg, this angle section is again classified into two subparts, that is equal angle section and unequal angle section. Then the IS flat plates having width B and thickness T, round bar of diameter D, square bars of size A by A, then plates of size of thickness T. These plates are utilized as an gusset plate to connect the members. So following was some introduction regarding the design of steel structure. Thereafter, we will begin with the design steps as well as the numericals. Thank you.